As we take a look at the concept of U substitution today, since that really is the method of doing chain rule in reverse, I'm going to start with just using some chain rule, doing some chain rule practice here. So actually just find the derivative, please, of this function to start with, specifically the derivative dy over dx. All right, and so in order to do that derivative, I end up having to do, for chain rule, remember, dy over dx, and actually let's go ahead and write it that way, dy over dx equals the derivative of the outer function times the derivative of the inner function. Now the outer function here is the sine of something, and so the derivative of sine is cosine. Now remember that when we use chain rule, that something on the inside stays exactly the same. The only thing that changed there was the sine to the cosine, but still of the 9x squared plus x. When we change it is when we multiply the derivative of the outside, which we just found, times the derivative of the inside. So now I do the derivative of that 9x squared plus x, which gives me 18x plus 1. And there we found the derivative, so we're done. That's all we got to do there. And that's chain rule, remember, just kind of bring that idea back. Right, now I'd like you to please find the derivative of this. And again, the derivative is specifically dy over dx. There is not a typo here. And so what can make this challenging then, though, is that, of course, it's not sine of x, it's sine of u. Well, that means that when we do this, we're going to be using implicit differentiation. And so I'm treating u as some unknown function, hopefully of x, otherwise it would be a really challenging one because we'd eventually have to turn into it. So we're going to treat it as a function of x. So then if I'm going to figure out what dy over dx is then, I end up doing chain rule again, where u is just an unknown function. And so I do the derivative of the outer function, so again that's going to be cosine of whatever's inside, that stays the same, times the derivative of the inside function. And the derivative of the inside function, that's the derivative of u. Now I'm going to get very specific here. That means it is du over dx. Because remember, that means it's the derivative of u with respect to x. I wanted to write it that way instead of u prime because, well, we're going to be making use of that fraction notation here in a little bit as we go forward. So with that idea in mind, please find this derivative, dy over dx. And so again, in order to do so, because that's a u in there, we're treating u as a function of x here. And so our derivative then is going to be using chain rule and implicit differentiation. So it's going to be 5u to the fourth times, now the derivative of the interior function, the derivative of u. So that's going to be times du over dx. Right, now having done that one, please go ahead and find this derivative. And typically when we do this kind of a problem, we're using chain rule, and so we just remember that we do the derivative of the outer function times the derivative of the inner function. And while that is true, I'm going to show you that in a slightly different way than I normally would do it. I'm going to show it using the U substitution. So I could actually do chain rule here by starting with U equals my inner function, ln of x plus x squared. And if I start by doing that, then I can know that y actually equals u to the fifth. And so you notice it becomes the same problem as the one that we just did on the previous slide. Just this time I actually know what u is, and the last one I didn't. Now again, you don't have to do it this way, but this is giving you a way to understand why do we use this u in the U substitution process. Alright, so I'm going to go ahead and find this derivative. So dy over dx is going to equal 5u to the fourth times du over dx. Okay, So dy over dx equals 5 times, now I can go ahead and plug in for the u. Notice when we do our u substitution, when we're integrating, the last thing we do is we substitute back in for u. And so that's the same thing here. And then times the d over dx. Now I don't actually know what that is yet, but I can find out. So I'm going to go back up here, and I'm going to figure out, okay, what is the derivative of u with regards to x? That is, what's the derivative of this? And so that is going to be 1 over x plus 2x. So I can go ahead and now plug that in down here for the d over dx, 1 over x plus 2x. And we're done. Now you still would have come up with that answer, and you didn't have to use u here. But that's because we can easily just think about it when doing derivatives of derivative of the outer times derivative of the inner. Well, technically, you're just doing that same thing in reverse when you're doing the integration. It's a lot easier to work with if we can use the u substitution, especially when they start not being set up perfectly for it, because you'll find that sometimes we got to do a little bit of manipulation. We're going to see that happen a little bit on some upcoming problems. So let's go ahead and get into that integration side. I'm going to start with what I hope at least is an easy one. Please go ahead and evaluate this indefinite integral. All right, and so to find this integral, notice I don't need to do anything fancy with it right at the start, so I can go ahead and start just with the antiderivative here. And so I go to my x, and I'm using power rule. So going this direction, that means I add 1 to it. And then normally I'd have to then multiply it by 1 over that exponent, because whenever we multiply by the reciprocal. But what's 100 times 1 over 100? 1. It just goes away. And so the integral of 100x to the 99th is just x to the 100th. With one little detail. What's the other little detail?
Plus c.
Yep. Plus c. We account for the plus c when integrating, because if there had been a constant on the end, the derivative, of course, would still equal the same thing. Now, if you can do this problem, you can do this problem. They're actually extraordinarily similar. It's just we're going to see some tips for seeing how and why they are so similar. All right, now, if you're really on top of things, you might be able to say, well, you know, I might be able to have gotten this by doing derivative of an inner function times the derivative of an outer function, and you might be able to see that right away, especially given the example that we just did. However, most people wouldn't, especially as you start seeing them come from all sorts of different directions. And so, this is where we use that u substitution. So I'm going to go ahead and start by defining u as the innermost function, basically. And so I got this power of 99. Well, whatever is to the power of 99, that's what I'm going to define as being u. So I'm going to use that as my u value. So that's 7x cubed plus cosine of x. Now from experience with these, I know I'm going to end up also needing to figure out what du is, right? And so I'm going to go ahead and now figure out what is the derivative of u. And this is a little piece here in terms of the work showing that I do want you to do, and it's going to help you a lot as we go forward. Remember, we write it first as du over dx equals. I'm not jumping straight to du here right now. And so then that's just telling me then, go ahead and find the derivative of u here. And so if I do that, that gives me 21x squared minus sine of x. Now I want to be able to substitute here. That's why it's called u substitution. So I'm going to go ahead and multiply both sides by dx. That gives me du equals 21x squared minus sine x dx. Yes, technically we would still have the parentheses there, so I'll go ahead and put those in. Now notice what that did for us though. 21x squared minus sine x dx. Up in my equation, I have 21x squared minus sine x dx. I have the exact same thing. So that when I do the U substitution, I literally am taking this whole piece that I just found that du equals, and I'm going to replace that whole thing with the du. So let's go ahead and write my new equation here. So notice there's actually two substitutions I'm doing. I'm substituting in the u and I'm substituting in the du. All right, so my new integral then. It's going to be the integral of 100 u to the 99th, because you notice this was u and this was u. And then remember the blue underlined part there? All of that is what du equaled, so that's why we write in then du. And suddenly this problem looks just like that previous one we did with the x's in it, except now it's u's instead of x's. So we can go ahead and find the integral, which means finding the antiderivative here. And we already found that's going to be u to the power of 100 plus c. Notice the du went away. Why did the du go away? Because we took the integral of du. The integral undoes the du. It makes it go away. All right, last step though. I don't want to leave this as my final answer because my original equation was in terms of x. I'm actually finding the original integral in terms of x here. And so I want to get my answer in terms of x. So we put the value for u back into the value for u. So our final answer then is going to be 7x cubed plus cosine of x. That's my u value. So that has to be to the power of 100 plus c. Now when doing the last integral, we really could just look at it and see, oh yeah, it's set up perfectly to be able to do the antiderivative using chain rule. Everything's exactly where we want it to be for a nice simple function. This one's not going to be too much more complicated, but it's not set up perfectly. Because you'll notice that if I just try to go straight to u to the power of 5 and take the integral of that, I'm not going to end up with something that gives me this. There's a few little details that are missing here. So I'm going to go through that whole process again, and we're going to see how it can help us out here. All right, so again, I need to start by figuring out what would my u equal. And u, of course, is the innermost function, so I'm going to make that the 2 plus x to the 4th. And because I know where this is going to go, I'm going to go ahead and find the derivative of that right now. And again, remember the derivative is du over dx. So the derivative of u with respect to x is just going to be 4x cubed. And if you're like me in this problem, you all of a sudden have to slow down every now and then and remind yourself, which way am I going? Am I going derivative direction or am I going antiderivative direction? Because if you're like me, you'll get them mixed up because we're using both in the same problem. So take your time with these so you don't run into those little tripping points. All right, and again, I want to be able to write this just in terms of du equals. So I'm going to go du equals, multiplying both sides by dx, 4x cubed dx. But you'll notice in this particular problem that we do kind of run into a little problem. Because in the last one, remember, I said, oh, well, I see what du equals up there. I could see that I have the x cubed and the dx that I can replace, but what about the 4? We got a little problem there. There's not a 4 up in the original. Now you can probably see how we're going to have to deal with it, but we can actually show that mathematically. Up here in the original, I have the x cubed, I have the dx. So I have those parts. So I want to know what that equals down here. So I'm going to take that 4 and move it out of that side. So I'm actually going to divide both sides by 4 here. And you have the option of writing as du over 4, but that tends not to be quite as intuitive. So I'm going to write it as 1/4 du, just because it's a little bit more intuitive and easier to work with here once we plug it in. And that's what x cubed dx equals. So now it actually equals something that is in the original equation. And so I can now actually substitute it. So this is that slightly trickier layer. Again, not super tricky. Right now it's just a matter of dealing with what do we do with the constants. But it's getting us set up to even deal with trickier stuff. All right, so then let's go ahead and now do our substitution. So I'm going to do the integral of the x cubed. That's going away from this. In fact, a nice little color coding can help us remember what goes where. And this 2 plus x to the fourth, well, that's going to be my u value. So then, really then I just have u to the power of 5 du. Oh wait, I forgot something. Yep. 1/4 du. So I'm looking to see what does that x cubed dx equal. And it equaled 1/4 du, so that's what I plugged in for that part. Right, now that I have it set up like this, I can go ahead and find the integral. So the 1/4, that's just multiplying by a constant. So it's just going to keep hanging out there. Now I do the derivative of u to the 5th. That's going to give me 5u to the 4th. See, it's lagging a little bit. Yep, it is. See? See? See what I tell you? This I know is what I keep messing up on. I keep trying to go the wrong direction. The 1/4 is still there. U to the 5th becomes u to the 6th because I'm doing the antiderivative times 1/6. So I know for me, I get in derivative mode. I keep doing derivatives. I got to slow down. I got to go back and I got to remember, oh wait, no, antiderivative now. I'm doing the integral part. And then we did the antiderivative, so then the plus c there. And then one last little step. We got to substitute back in for the u. Oh, and I guess we can also clean up that 1/4 times 1/6, right? So the whole thing then equals 1/24 times 2 plus x to the 4th. And that's now to the power of 6 plus c. And we're done. I'm thinking you should be able to work this one yourself, but I'm going to go ahead and start putting up the work here so you can be checking it as you're working. And you notice in this case, I didn't just leave it as du equals 3 dt. I didn't have the 3 in there already, so I just figured out what does dt equal. And I'll be substituting all of this in for dt. And so in this case, we end up with an answer of 1/9 u cubed plus c. Well, I guess that's not final answer though, right? Gotta do one more step. And then if you actually want to check and make sure that we're doing this right, you can always check yourself. You can always check that you came up with the right answer by figuring out what is the derivative of the function you just found. So this is done. This is right. But I just want to show you, how can we know that for sure? Well, if I took the derivative of that, I would get 1/9 times, and I'm going to use chain rule here, so derivative of the outer function, that's going to give me 3t plus 2 squared, and then times the derivative of the inner function, which is just 3. And so you notice when I do the 1/9 times 3 times 3, well, those all equal just 1, and we're left with just 3t plus 2 squared. And so yes, we do end up with the same thing that we started with in here, the same thing that we are integrating, so we know we got it right. So if you're ever not sure, you can check it that way. So next up, let's tackle this one. It looks a little bit more complex perhaps, but actually same methods, same process. For some people, when we deal with e to the power of something, finding the inner function is the toughest part. Normally we'd like it to just be e to the x. Since it's not just x, that represents our inner function. So the x cubed, that's what we're going to make our u value. And as I find the derivative now of u, I can go ahead and get du over dx, then write that in terms of du, but then I look at what I just found for du over here, and I look see, okay, now what of that is actually up in the original function? Well, I got the x squared there, and I have the dx. So the x squared and the dx I can substitute with the du, but not the 3. So that means I got to move the 3 out of there. And then I actually have something where I can substitute, because I know that the x cubed dx, x squared dx, that's going to be entirely replaced when I do the U substitution. Just like the x cubed, well, that's going to go in for the x cubed here. And then once we've completed all the substitution where it's just u in here, by the way, notice when we do this substitution, it's only u in the equation now. You'll never want to get to a place where you have a mix of u and x in this equation. When you get rid of the x's, get rid of all the x's. And so the antiderivative here is just e to the u times 1/3. So then our final answer will just be 1/3 e to the u, we got to have our plus c in there, e to the power of x cubed plus c. And if you wanted to write it as e to the x cubed over 3, of course that's the same thing, and so it would be perfectly fine.